My name is Muhammad Awais, and today I'm gonna be talking about my project called Bifacial Photovoltaic Thermal Performance Evaluation and Tracking System. So the basic aim or objective of this project is to improve the solar efficiency uh, by using an optimal tracking system and also increasing the output power by using bifacial solar cells, which is a relatively new technology. So why do we need this project? So we know that over the past decades, different technological advancements have led to the increase in energy demand, and so far these demands were fulfilled by fossil fuels, mostly like oil, natural gas, coal, which were very harmful for the environment and caused global warming, and they're also limited. So we need some alternate energy sources, which were renewable energy sources, like solar, wind, hydro, etc. And they are clean. And now, since we are turning towards renewable sources, our dependency on them also is increasing. And one of this, the renewable energy source is studied in this project, which is solar energy. So it is the most abundant form of energy available to Earth. It's free energy coming from the sun in form of irradiation. So, and this irradiation is converted into electricity with the help of solar cells, and it is the most commonly used on domestic and commercial scale as of now. And we can see in the graph that over the past 20 years, the installed solar capacity has increased exponentially, which highlights the significance of this energy. But the problem connected with this solar energy is low efficiency due to different reasons, like increase in temperature and not tracking the sun during the day, which reduces the radiation value is tracking on the surface of solar cell. So in this project, we improve the efficiency with the help of optimal tracking system. There are two phases in our project, and one is lab experiment, and second is experimental setup that is on the roof of the central building. We used a prototype of bifacial solar cell with a reflective surface underneath that small cell in the lab, and we used a high power and high intensity LED light. So what we noticed that the power output of the cell increased when the bifacial solar cell was used with the reflective surface compared to when a black or non-reflective surface was used underneath that cell. This was due to the extra radiation that was scattered around the environment of the solar cell and not striking the upper surface, and they were hence not producing no electricity. But using a two-sided solar cell increased the power output. So then we turn to roof setup, which has four different stands that will hold the solar cells with different reflected surfaces underneath them, as you can see in the picture. And the fifth stand would house a weather station, local weather station with different sensors that will give the real-time data on the weather of the roof. So far, we have been delayed due to a number of reasons, but mostly delayed shipment of different components we required. So as of now, the cable bridges are installed. That will hold the bundle of wire for powering up the motors and output power from solar cell and sensor data in input output all the different components. And we have discussed the sensors positioning in the so that we get the required function of the sensors, and graphic user interface for monitoring different values from coming from the sensors and the outputs on the solar cell, and different parameters have also set up with on that. This will be used with along with the SQL server that was set up by a private company. And lastly, there's been addition of the vibration center that was not previously part of the plan. This is due to the safety of frame. So accelerometer is basically used as a vibration center. It's basically a device and that measures the acceleration of an object. And it is used with the safety of frame because when the winds are strong due to the height, so and the strong winds don't damage the structure of the frame. And also, Syntax received an order from an industry that has a big production plant with a lot of motors installed. So to monitor the vibrations on the motors, we also needed the accelerometer. So to install accelerometer, you need to consider some features which are discussed. First is measurement range. So this is the one of key features or specification of the sensor, that maximum amplitude of vibrations that can be measured with the sensor is its measurement range. It comes in G's, or gravitational acceleration constant, that is 9.8 meter per second square. So there are sensors available up to 20 Gs or even higher. Bandwidth is the range of frequency signal that can be sampled without aliasing or distortion of the output signal. So it's also a very important feature that must be kept in mind. Sensitivity is the rate at which the mechanical movement is converted into electrical signal. So for digital accelerometers, it's measured in less significant bit per G, and for analog is millivolt per G. Resolution is the next key feature. Resolution is the minimum or smallest change that can be measured or detected by the sensors. It's usually used with the digital accelerometers, and its measurement is calculated by taking the resolution bits. Let's say if you have a 8-bit accelerometer and its measurement range is 3G, so you divide 3 over 2 raised to power 8 or 256, so you get 0.011, which is the least value you can measure. Then last is number of axes. So it's the number of axes is like how much axis your sensor can measure the vibrations along. So there are one or two or triaxial sensors available in the market. For industrial applications, as I mentioned, that it will be mainly used for measurement in motors. So there are a number of different faults, that looseness, belt drive, cavitation, etc. But the main faults that will be discussed are misalignment, imbalance, gears, and bearings. That these are the most common types of fault occurring. Misalignment is when two connection points are not aligned, and imbalance is the uneven mass distribution For example, in a fan of induction machine, if there's a one broken blade, then it will swing or vibrate, and which can damage the machine. Similarly, gears, the problem with the teeth or not perfectly placed gears also cause the vibration, and bearings. Their transmission of they're useful for transmission of load and also used in a rotation part of the machine. So and the monitoring is also very important for these. So the result is from this research was that there are a number of expensive solutions that are available, but and their cost was too high. So I discussed with my supervisor, and we agreed that we should try to build a custom sensor with the cheap sensor in it, and the wireless transmission device, along with wireless transmission device and a microcontroller that will complete the requirements of the customer. But we have to check that as it's not proved or tested as of now. And then the next phase of the project, that is the integration and installation of sensors and getting the data from the sensors, and then using that data to track the sun in an optimal way, so to keep the power maximum. And the in the future, the improvements of this project can be the study of the economical cost and the benefit with it, and the performance of these bifacial solar cells, that how they perform in the hot climate areas, and also new design of solar cell that will use small water tubes on the backside of the plate to circulate water, and they will absorb the heat from the surface to keep the temperature minimum and efficiency high, because increased temperature reduces the efficiency of the solar cell. So that's all. Thank you for your attention.